Okay. So if you need to watch again after we're done, you can. Okay, so let's try it again. So I'll do 1, -1, -9, and 1. So now I'll put -1 on the outside. Bring down this. So now it's -2, 2, -7, 7, and 8. Okay. Unfortunately, none of those work. Um, so do you remember what trick your teacher told you then? That's what I thought the trick would be.
No, the way he does it is that um, every day it's like, oh, we're going to do a warm up, and that takes like 15 to 20 minutes.
Okay.
And then um, after that, he says, like, oh, you write stuff on the board.
Well, what's probably going to happen here is that this is going to be a really weird situation. I mean, I go to Desmos to see what's going on there, but I'm a little surprised he gave that to you because I don't know what trick he's talking about. Be kind of very frank about that. X cubed minus x squared minus 9x plus 1. Yeah, see, it's such a wacky number. So it's not factorable. I don't know what the heck he's talking about. I don't know. I mean, maybe there's a radical that makes it work. I don't know. But I'm clueless. I have no idea what he's.
Yeah, it's like
It's
it
not
lets you
factorable.
on the board, and like the only stuff that we're given to study is essentially this homework.
Okay. Well, let's look. I know three is factorable. Let's talk about three. We'll worry about two later. Maybe I'll look it up if we get a chance.
What
Okay.
the,
So do you remember how to do three?
I'm looking.
You have four terms. And look at the first two and last two.
Yeah, from what I'm seeing is
So let me give you a little hint.
okay.
Put parentheses around the first two and parentheses around the last two. What can you factor out of the first group?
Two.
No. Let's go back. You have x cubed minus 2x squared. What did they have in common?
They have X.
What was that?
They have X.
Yeah, x squared.
Yeah.
So you get x minus 2. Let's look at the next one. What did have what did those excuse me, what do those two have in common?
They're both factorable by two.
More higher.
Four.
Higher.
Six.
Not 6.
Eight.
Higher. 16.
Oh wait, yeah.
So you take it -16, what's left behind?
Yeah, if you take it's two.
X minus 2, right?
Uh-huh.
Look, now those are the same, right?
So they factor out, and then you get X squared minus 16, and
Good.
then
Remember, good. And then you can go even further. How do you break apart x squared minus 16?
wouldn't it be +4, -4?
Good. So that's a pretty straightforward one. I think, definitely look for those, like 1 and 3. Those are going to be the some early wins. So not get those out of the way first. And I know you can recognize those, so not worry about that. Do you happen to have your notes on something like number 2?
Hmm?
Do you happen to have any notes on a question like number 2, like your notes from Monday?
Not really.
It's all right. Don't worry about it. It's all good. Okay, 4. 4 is not factorable, so I don't know what the heck he's talking about. Because what you do is you multiply A times C, and you put B down here, and you try to find two numbers that multiply -74 and add up to 12, but that's impossible. So I mean, you could do quad form if you want. I'm not sure if that's what he's looking for you to do.
Four.
So B squared minus 4AC. The problem is that it's not gonna be real. Actually, no, sorry, it's not gonna be rational. Um, let me get a calculator. Hold on. Hmm. 4 times 37 times -2. 144 minus that number. You get 440. Um, you could say -12 plus or minus 2 root 110. You take a 4 out. Maybe you want to say x minus that number and x plus that number. That's the only thing I could think of. I don't know. I mean, you could do this. And then
Oh,
x minus -12 minus 2 root 110.
for 2 and 4, he's wanting us to do long division.
But even then, there are no integers or rational numbers or factors of it. So I don't know what the heck he's talking about. Like, sure, you could long division all day, but the fact is, those are x-intercepts. They're irrational. So I'm not sure what he's referring to. Um, anyway, let's move on to the next problems. Okay, he said elimination might make this easier. So I would probably consider adding these two equations. What happens when you add those two equations?
You would get 2x 3y equals 19.
I'm sorry, repeat again.
2x 3 plus 3y equals 19.
Perfect. Then let's subtract these two.
Okay, yeah, if you subtract them, wait. Yeah, if you subtract them, you're gonna get negative x,
Good. Keep going.
negative x plus y, negative 2z.
Plus 3y.
But oh, yeah, sorry.
And the z's will cancel because they were the same sign.
Oh yeah, because it's
So now, how do you work that out?
what? What'd you say?
How would you work that out? What I haven't read?
Yeah, well, you would put them to wait.
So should I add or subtract those equations? What if I subtract these two?
Yeah, if you subtract it, you'll be left with x.
3x equals what?
3x equals 22.
Oh, you gotta be kidding me. Teacher gave you a fraction? You gotta be. Oh my goodness. That is insane. Um, that's kind of crappy that your teacher did that. Hold on a sec. That is messed up. Well, then at this point, you're going to plug in 22 thirds 8 into either equation. Let's make sure we do that right. Negative x. Yeah. Yeah. Geesh. Not fun. Yeah, then you have to work that out. So 3y equals 19 minus 44 thirds. 19 could be made into 57 thirds. So it comes 13 thirds. So y is 13 ninths. And then you can solve for z by plugging in the values for x and y to one of the equations. So that's 66 out of 9. That's 79 out of 9. Um, 7 can be thought of as 63 over 9. Move it over, you get negative 16 out of 9. Hope that makes sense for that one. I have a calculator where I can verify the answers. I have an app. Do you ever still have a graphing calculator from high school?
Uh, I don't think so.
Okay, left back Palta.
Either that or it's in my dorm room somewhere.
Okay. By the way, it looks beautiful out there in Denver.
Yeah, it's at this time of day, the sun comes in from the southern.
That's gorgeous. Um, yeah, there's an app on here. I'm just gonna double check our works, make sure we got it. 1, 1, 1, 7, 1, 2, -1, 12, 2, -1, -1, 15. Solve it. Yep. Those answers come out correct. It's just kind of crazy teacher gave this fraction. What's the name of this course anyway?
Hold on. It's like math. It's math 1070 or something.
Okay. I mean, it's just kind of crazy teachers giving you those wacky numbers, but let's look at 2. 2 is a very typical one. How'd you do 2?
No, I have it right here. Hold on. Common out algebra and trigonometry.
College algebra, got it. Okay, that's what I figured. Okay.
Um,
So 2, how'd you handle 2?
well, what I wait, well, the way I did it was I swapped out the 8.
You what? Sorry.
What I did was I swapped out the 8 for negative y.
So you're doing a 2x minus 8 equals y.
Yes.
Okay, good. Then we do after that.
After that, I believe I don't remember what I did.
What you want to do is you want to substitute 12x. So you might want to write this out. Do you have some paper?
Yeah.
Because it'll be good for you to do the arithmetic. So this equation, let's solve that now. I'll give you a sec.
Um,
Okay, you solving it?
you would factor in 13. You would get
You
20.
distribute, right?
yeah, you get 26x minus 104. So then you add 26 to 12, you get 38x minus 104. You add 104 to 7, and you get 111. And then you divide by 38, which should be a fraction.
Well, so you should get 12x plus 26x minus, you said,
104.
geez, you're teaching us fractions, 111.
38.
All right, well, it is what it is.
Yeah.
And then just substitute. And I know you can do that afterwards, so I'm not too worried about that.
And then you put it in.
Oh, hold on a sec. Okay. Um, so next up, let's do 3. What I recommend you do,
Yeah, with 3, how do I do it? Yeah, minused, I subtracted x plus y plus z 12 from x plus 2y plus z. So then I got y equals 6.
I'm sorry, what did you do?
I minused the first set, the 1 equals 12, from the second set, 18, and I got y equals 6.
Wait, y equal. Oh, that's smart. I like that. So you did elimination. Okay.
Mm-hmm.
Hold on. If you subtract it, yeah, you're right.
Yeah, I got y equals 6.
Okay.
And
Yeah, then you
then,
should get
yeah, everything I got.
x plus z equals 6. And then for the other equation, you could say 2x plus 2z equals 12. Because that becomes 18. The problem is that they're going to be identical equations. If you multiply the second equation by 2,
Mm-hmm.
and that's 0 equals 0, which is infinitely many solutions. So we don't want that. Well, we don't want that. You just say infinitely many solutions. That's your answer. So you could say, you have all terms of y, I suppose, or in terms of x. So y is, or you just leave it like that. It's just infinitely many. Yeah, it's just like x. Yeah, you could leave it as like x, comma 6, comma 6 minus x. That could be your general solution. Because you know the relationship between x and z is that. I'm guessing that's probably what your teacher's looking for. So,
Yes. Yeah, and then, well, the last one, it's fairly simple. I got,
yeah, give it a try.
yeah, first y equals z. So the top question is just z minus z. So then you just get x equals 12.
Okay.
And so then I plugged in 12 for 2x. So then I got 24. At 24. Wait, how do I do it? Oh, wait, yeah. Um, I put in 24. So then that would mean
Okay.
that for the bottom equation, y must be -3 to make it 0. And so since y equals z, now z would also be -3.
Correct. Okay. Okay, perfect. Okay, so that covers this. Again, I don't know what to do about 2 and 3, the first set.
Yeah.
You said long division, so we could do long division right now if you want to do that.
I was gonna say that. And
Yeah,
then if we have time, I'm gonna ask about something else.
right. So let's see here.
I understand the basics of long division, like if you divide by 7, but I can't do.
Yeah, we'll do some crazy ones.
Yeah, I'm not familiar with like x plus 1.
And give me one moment. I'll be right back. Hold on. Oh, there it is. All right, sorry about that. Okay, hold on a sec. Okay, so let's see, let's keep on doing. Here we go. So let's take a look at, say, number one. What you want to do is put x minus 1 on the outside
Yeah.
and put x cubed plus 3x squared plus 3x plus 2 on the inside. Okay, then what you need to do is you need to figure out how many times x goes in x cubed. So what would that be?
Um, wouldn't it be one time?
X squared times.
X squared.
So you want to put x squared right here. So it comes x cubed minus x squared. Then you subtract. X minus x cubed goes away. What's 3x squared? So what's 3x squared minus x squared?
Wouldn't it just be X?
It'd be actually 4x squared. Because you need 3 minus negative 1.
Oh.
And you bring down the 3x. Okay, then you rinse and repeat. What do you multiply to x to get the 4x squared?
4X?
Exactly. Good. You're getting it. So you get 4x squared minus 4x. Subtract again. You get 7x plus 2. You do it one more time, you get plus 7. 7x minus 7. And you get 9. So hopefully that makes sense for that one. So that's how you do it. And it's really just a cosmetic change. It's really still the same thing. Just looks a little different, that's all.
Uh-huh.
All right. So let's try it again. Let's do it for number 2. Well, why don't you go and write it down? Because once you get in practice of writing it out.
Okay. So How many times does x squared plus 1 go into 7x cubed? It would go into it once, right?
7x. Basically, what would you multiply? That's what you're being asked. Like, what would you multiply to x squared to get to 7x cubed? So it'd be 7x.
Okay.
Okay, then you gotta multiply x squared plus 1 by 7x.
Can you say that again?
So what would that be?
Can you say that again?
You gotta multiply these two together.
Okay. Yeah, you would get 7x cubed plus 7.
Good. Plus 7x. And you have to line them up like this. So they go with their like terms. I put parentheses just so I distribute the minus correctly.
Okay.
So what happens when I subtract those?
Well, you'll be left with 0. You won't have anything. It goes into them equal. Yeah, equally.
Yeah, they'll all go away. So you bring down the 11x squared and the plus 5. And that goes in 11 times. Subtract again, you get -6. So minus 6 over x squared plus 1.
Right.
And that's your answer.
11. Okay. Okay.
Hope that makes sense for that one.
It's starting to.
Good. Okay. All right, so that's long division. You said rational roots.
Yes.
Okay. So let's do something like number 5. I think that's gonna be more typical of what you'll see. Um, one sec here. So what are factors of 24 of -24?
Uh, what are factors in -24?
Mhm.
Well, you could do +12, -2.
Okay, good. So plus minus 1, plus minus 24, plus minus 2, plus minus 12, plus minus 3, plus minus 8, plus minus 4, plus minus 6, right?
Mm-hmm.
Okay, good. Okay. Now you're going to test those out by using synthetic division, because long division is going to be a little too crazy. So 1, -12, and you're not allowed to use a calculator, right?
I believe so. We're not allowed to.
Okay. So you test 1 out, you bring the 1 down, you multiply, add, and look here, we get really lucky. That works because you get 0 right there.
Okay, how did you do that though? What you just did?
Okay, let's back up. Okay, do you see how I set it up first?
Yes.
Okay, perfect. So now you see the setup. What you want to do is you want to bring the 1 down like that. You see that?
Yes.
Okay, then what do you think I did next?
Well, what I want to know is that how did you get the 1 from the front?
Oh, that's because, oh, you mean the one on the outside?
Uh-huh.
Oh, that's because when I did all that stuff earlier on, when I listed all these factors, one was one of the possibilities.
Okay.
That's where you have to list all the factors first to see what to test out.
Okay.
Okay. Once you have that done, so then you just start testing and you want 0 at the end.
Mhm. So you have 1 times 1, you get 1.
Okay.
We have 1 times 12, you get negative 12, you get negative 12.
No. What you do is
Oh.
after you multiply the 1 and 1 together, you put 1 right here.
Okay. And then you get negative 11.
Then you add those, right? Negative 11. Okay.
Then do we put negative 11 on the below 35?
So you put negative 11 down here.
Okay.
You
Yeah,
put
negative 11
24.
there. 24. You get 24 there. You get 0.
Okay. That becomes x squared minus 11x plus 24. How do you factor that?
It would be 7 and 4. Wait, no.
8 and 3.
Yeah.
Right. So you should get 8 and 3 for that one. So, okay. Go and try this again for, say, number 8.
Okay.
So what right so once you're writing out, write out all the factors
Uh-huh.
of 9.
Of 9.
So what are the factors of 9?
Oh, okay. 8, okay. Factors of 9, you could just get 1 and 9, 3 and 3. Yeah, 1 and 9, 3 and 3. Yeah.
Yeah, okay. So what I want you to do is do synthetic division again. Go and set it up.
Mm-hmm.
And what you want to do is go through the motions like we just did earlier. But this time what you want to do is set up like this. 2, -7. Now x is skipped over, so you gotta put 0.
Okay.
Anything gets skipped over, it's same thing along division, skip it over, and you're gonna put 1 right here.
Wait. What did we skip for 0?
Oh, because there's no x. There's no x term, so it gets skipped
Okay.
over.
Okay. Yeah, so you put in 1 times it, you get 2. Put 2 below 7, you'll get negative 5. Put negative 5 below 0, um, you still get negative 5. Put negative 5.
Okay, so it doesn't work.
You put negative 5 below 9, you'd get, yeah, you get 4. So it doesn't become 0.
Okay. So 1 sec here. So yeah, because you bring the 2 down. 2, -5, -5. Yeah, you're right. So let's make it a -1. You bring 2, -2, -9, 9. I think it's gonna work. Yep, it works. So you get 2x squared minus 9x plus 9. Um, then we want to factor that.
Yeah. Like 2x. Well, yeah, for this, for that, uh,
Or you can do quad form too.
hmm?
Or you can do quad form.
I can't hear you.
Or you can do quadratic formula.
Go on.
You could use the quad form if you want.
Okay, how would I do that again?
Do you remember the quadratic formula?
Remind me.
A negative b plus or minus b squared minus 4ac.
Yeah, no, I don't remember that. I'm sorry.
Hold on a sec. Let's go wash my hands.
Sign.
Okay. So yeah, it's negative b plus or minus square root of b squared minus 4ac all over 2a. Remember that?
Yes.
Yeah. Yeah, so you could do, I'm just on a call. Yeah. So you could do that, right? You could plug in negative 9 for B, 2 for A, and 9 for C.
Wait,
That could work, right?
negative 9 for C or positive 9?
No. A is 2, B is negative 9, and C is 9, right?
Okay, so yeah, we would have positive 9.
Good.
Yeah, positive 9 square root negative 9 squared.
It's 81.
Yeah, 81 minus 4. Yeah, 2, 9, 4.
Right.
5 by 4.
So you should get 72 on the inside. 81 minus 72 is root 9. So you have 9 plus or minus root 9 over 4. Or 9 plus minus 3 over 4. So you get 12 over 4 or 6 over 4. So you get 3 or 1/2 or 1.5.
Mhm.
So that's what you get for that one.
Okay.
Yeah. So hope that one makes sense.
Yeah.
Okay. Let me have you try it. Let's see. I do have to end the call in a few minutes because I have to get ready for class.
I need. Then I'll ask you a quick question.
Yeah, fire away.
For like injective and surjective stuff.
Wait, sorry, repeat that again.
Injective, surjective.
What's that? Let me look that up. So, what is that supposed to be?
It's for functions.
Injective and surjective?
Yeah.
That's weird. Hold on a sec. Injective and surjective. I don't know. Oh, okay. There we go.
Yeah, I understand. Like, injective means that they're all that
There's
they're
1-to-1.
yeah they're injectives. There's no repeats.
Right.
Surjective means they're all filled.
Correct. Yeah,
But
that's what it looks like. Yeah,
what?
that's what it looks like. I mean, I've never used it. I use 1-to-1. I've never used injection before. It means for every input, it has what's one output and vice versa.
Yes.
Um,
Do you know what this is?
that's just for sets. That's just for functions. That's just like if you have numbers. Like for example, if you
No,
have
but
1, 2, 3, 4.
I need help trying to understand how to find which one's which from just
Yeah, no, if it just does this, that's injective.
but like not like that,
That's
like
all.
a in out problem.
Oh, do you have a problem to show me? I don't know how he's gonna ask this question.
Um,
He might just give you a table and say, is it which one is it?
no, he doesn't give us a table. Like it, like an example would be like if it's weird. It's like
Do you have a sample problem I could look at?
let's see.
Yeah, because I've never heard of that before.
Yeah, no, I don't. It was basically you have brackets, let's say 0, 1, and like 0, 1A goes to 0, 1B, and that means that any number you have must be between 0 and 1. It's weird. I was just double checking to make sure.
Um,
If you don't know it, it's fine.
no, I never heard that before, so I don't know what that necessarily entails. So this seems weird to me. Um, okay, well, I think that kind of covers. Well, I just got one sec here. Stop sharing. Stop recording.